Hello! Welcome to the Two Mics, One Joe show. Hello, Mike.
Hi, Mike.
Hi, Mike.
Hi, Mike.
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 Oh, Mike.
Mike.
Wait.
Mike. Wait.
Mike. There's three mics. No Joel.
There's a problem.
We need a Joel.
Yeah.
I think
Joel.
he
Mike.
should be Joel.
You're promoted.
Mike.
You're
Yeah.
Joel.
Joel.
You're Joel. You're now Joel. You're
I'm
the
Joel.
honorary Joel.
I'm Joel.
Well, we're here today because we're here to discuss everything we found. Well, not everything, but certain things that we found interesting in Mr. Canada's classroom. He taught us throughout the year, almost all year for us, most of the year for him.
Mike wasn't here.
Yeah, Mike came in a little late.
Mike did.
Yeah, but me and
Joel's been here the whole
Joel,
time.
we've been here the entire time. And throughout the time, there are certain things that stood out to us. And that's what we're here to talk about today. 10 things that we found the most popping.
Top 10 in no specific order.
Number 10. Binomials and trinomials. This is pretty early in the year. It was something introduced, not so much. It was sort of review. It was something to get us on track of the algebra, because we just came back from geometry, so it's a little confusing. So what binomials and trinomials were is you were given a certain amount, well, different digits, I guess. Different values, there you go. Whether or not they had variables or it was just a coefficient. It was given and you had to combine like terms, and there you go. You were either given a binomial, a trinomial, or a polynomial if it was more than tri. 3. And later on we would go on to start dividing polynomials, and we were multiplying binomials to get trinomials, and we were factoring trinomials. But we'll get back to the factoring.
Number 9.
What is this?
This, my friend, is a number.
A number.
Yes, you just have to use your imagination.
Your imagination?
Yes, your imagination. In math, this is considered a complex number, which you'll probably see in when you're trying to square root a negative number. For example, the square root of -4 is 2i. The I is just because there's no real solution of negative square roots, so we use the I as one. But don't be confused. When you have an I squared, that would be equal to -1. So if you find that in your equation, don't forget to translate it into a -1.
Wow.
That's not a complex number. Now that there's factorial. That's number 8.
Yeah, we'll get to that later.
Number 8.
So, if I put a 3 in front of here, what would that be? Mike?
3.
No.
3.
Thank you, Joe. That's wrong. It would in fact be 3 factorial, which would be 6. Because with a factorial, you would do 3 times 2 times 1, which would be 6.
What if it was a 6 instead of a 3?
If it was a 6, you would do 6 times 5 times 4 times 3 times 2 times 1, which would be, what would it be? What would it be?
220, 240, 360. 360, I got lost. 360, 720.
720 kids. And like a way to remember is how many times you could rearrange a set group of numbers before it repeats itself. Like if I had 3 markers, how many times could I arrange it without it repeating itself? Which factorials helps you solve it in way faster form.
Bonus round.
Daily. 365 days.
We're not in school 365 days.
You might not be. Anyways, our fun fact is...
We'll recap on one he previously said, which was that Leonardo da Vinci could draw and write at the same time. What's the word? Pretty well.
Pretty well, yeah.
Pretty well.
And so,
We would like to demonstrate, you guys.
Yes.
We will try
2
out
pens.
our drawings and we'll show them to you. So
Yeah,
give us,
and writing, because we're gonna write with one and draw with the other.
Alright, so
And
let's go.
yeah, yeah, it's coming out great, guys. Ooh,
You done?
I don't know. Are you done?
Yeah.
All right. Wait, finishing touches on this one. Whoa, amazing.
So,
Well.
we'd like to show you guys our pictures.
Oh yeah, clearly. This is our picture. I think we should get closer. Yeah, yeah. This is the picture.
Come on, Nkechi, why don't you move?
Yeah, Nkechi, come on.
This is mine.
Artwork. It's beautiful, ain't it? And this one's mine. Well, the camera even sees it as a face. It's that well made.
Alright.
And our writing.
Is
Our writing. This is our writing. As you can see, we could be like the next Da Vinci or something, right? I like pie. Who doesn't, right?
But car is fast.
Because all cars are fast. Yeah, and that's our bonus round.
Stay tuned for more top 10.
Number 6. Factoring. Factoring trinomials to get binomials. The process of this was easy for me to get. For other people, it wasn't too much. Thankfully, people like Alex or
You mean Joel, right?
I do mean Joel. I don't know where I honestly
I
you look
don't-
like an Alex.
You might be an Alex.
You look like an Alex.
Yeah. But thankfully he's Joel.
Yeah, you're Joel.
Yeah, Joel, right here.
People like Joel or Mike, we were there to help out people who didn't really, well, Mike wasn't there, didn't really understand it. And that was sort of something that was encouraged in Mr. Hannah's class, was helping each other, was helping each other out. Now, the whole process could have been divided in 3 ways. There was completing the square. Wait, no, never mind. My mistake. The whole point of factoring was to get 2 separate binomials, which either could have been the same one, but twice, or 2 different ones. Just to sort of split it apart so it's easier to understand so you can find x. And that's the entire purpose of factorials, of factoring. Factorials is a different topic. You would set the factors, the binomials, to 0, and that's how you find your x.
And now, a word from our sponsors. Whoa, these papers though. Dang, fam, you always do this to me. You're lucky I'm scared of you. I wish I had a paperweight or a way to terminate you.
Well, now you can with the new paperweight.
What is that?
It's a paperweight and a way to terminate the fan.
Could I try that?
Yeah, why not? Perfect.
Oh, I have this
safe.
Whoa, this works.
Yeah, you see? And
So you said you could terminate it. How?
yeah, exactly. You just prep it and you just prep it and you eject one of the projectiles out
How do you eject it?
with the squeeze of your hand, Sonny.
Are these special staples?
Glad you asked. They're platinum. Platinum. And for a low price of $100 each, you could own one stick.
Oh, could you try it?
Yeah, look at it. Look at it. Ready?
Whoa, it really works.
Yup.
Thanks, mister.
You're welcome, Sonny.
Where can I get mine?
In stores.
What's the number?
1-800 stable now.
Call now. Welcome back from the Two Mics, One Joel show. I'm Joel.
I'm Mike.
We need another mic.
We do.
Mike.
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 Hey, you're not Mike.
No, not Mike at all.
Not Mike.
Mike.
Whoa.
All right. Mike.
Mike. I'm
Mike.
promoted to front line.
Mike 2.0.
So again, Joel
Mike.
and Mike. Two mics, one Joel.
Like it should be.
Number 5.
Number 5.
Quadratic formula.
Should you sing the song?
There's a song.
Yeah. It's well known.
Oh, okay. CAMPFIRESONG song. Oh, that's SpongeBob. X equals negative v plus or minus square root b squared minus 4ac all over 2a. Yeah.
All over 2A.
So what's the quadratic formula used for?
I don't know. You told me. Shh. Do I look like a scientist?
Kind of.
Oh, thanks, man.
The quadratic formula could be used to make parabolas.
When you graph them, though, right?
Yeah, when you graphing them.
And we'll be learning about parabolas pretty soon. Number 4.
Wait, what? There's something back here.
Oh, wait, what? Oh,
Where
hey!
are you leaving?
It's our guest star.
Hi, Mike. That's your name, Mike.
Yeah, his name's Mike.
Alright, get out of here, Mike. Don't come back. Why are you behind this pillow? Alright, so anyways, number 4.
Number 4.
4.
That's
4, 8,
yeah, that's 12. You're still up. 4. 12 divided by 3. Yeah.
the parabola.
La parabola. See it?
Yeah. Is that positive?
Yeah, it makes me really happy. Yeah,
Happy.
happy. It's positive. And if you make it negative, it makes me really sad.
What type of equation would get you a parabola?
And a quadratic function.
Oh, okay.
Quadratic equation. Yep. Then you know, interactive right here. Hey there. You can start to see Joel right there. Boop, 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 boop. Boop, 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 boop. Oh, okay. And So you see here, nah, paper, you know, right here and right here is the x-axis, shows you your roots, and this is your y-axis, and it shows you your axis of symmetry, and yeah, that's a parabola, and that's your vertex right there. Woo. Number 3, you know, 3D. Take it away, Mike.
I couldn't have said it better myself, but I will.
Take it to shore, Joel.
Logs. Logs are...
You mean log cabin syrup?
No, not log cabin syrup.
Did you need a log?
No, not a log. Mathematical log. Logarithms.
Oh, never mind.
I'm gonna save this for later.
So, Mike, logarithms are the power to which a base must be raised to equal a given number.
What's that in your hand?
Nothing. For example, logs. Log 100 equals 2. Log 100 equals 2. Because 10 to the power of 2 equals 100.
Log up to the base of 2, 8 equals 3.
Explain why.
Because 2 to the exponent of 3 equals 8, you know. 2 times 2 times 2, that's ocho. Yeah, that's an 8. What number are we at?
Number 2. No, that's one. That's number 2. Jesus. Peace. People are waiting.
My heart's on this side.
Mics are waiting.
Mics around the world, right? So, here we are to learn about Pascal triangles, not circles. Pascal triangles are used for to expand binomials. They're like used for stuff that have an exponential thing above higher than 2, most likely. And it's a Pascal triangle right here. Yep. It's beautiful.
How do you compose one of those triangles?
Well, not glad you asked. You would compose one of these triangles by, well, you start off with 0 because 0 still holds a spot. Yeah,
So
0
the
is
first
still
row is
1.
the first row is 0.
There's an invisible 0 right there.
Row 0, row 1, row 2, row 3, row 4, and so on and so on.
And
To
Like-
compose it, you would add the 1 and the 2 to make 3, and then there's ones on the outer sides, but you just add the two numbers next to it to get the number in the middle. So like 6 plus 4 is 10, 10 plus 10 is 20, 5 plus 1 is 6, and so on and so on.
And there's many little tricks to it, like going diagonally. It's 2, 3, 4, 5, 6, 7, 8, 9, and it goes on forever and ever and ever and ever and ever. And exercise. And a Pascal triangle is used, like I said, to expand binomial and Pascal triangle. Here at the Two Mics and Joel show, we take life very, very seriously.
Very seriously.
Very.
Which brings us to number 1.
Number 1. which is life lessons.
Life lessons.
Yeah, lessons of life.
So, a life lesson that I have learned was that, well, math is universal. It's the same in Beijing, in Mexico, Africa, like in everywhere. It's the same.
World.
World.
And I've learned that life is like a box of chocolates. You never know what math you're gonna get. Yep, that's pretty important. Mike, would you like to add something?
Come over here, Mike.
Alright, Mike. Come over there. Come on, don't be shy, Mike. Say something.
I would just like to say, remember kids, you could prevent wildfires. Yes, you could prevent wildfires.
Man.